Okay, tadi my Webex went wrong. Okay, I think I was at explaining on what is gradient illusion is all about. Okay, so previously I mentioned what is isocratic. So basically you have maintained your composition or your mobile phase composition, constant mobile phase composition throughout your chromatographic run. So basically the ratio is going to be the same from the beginning up until the end. While for gradient illusion, you change the composition. Okay, you change the composition in terms of, okay, for example, you have just two reservoir up there, up onto on the solvent reservoir, you have two bottles only, you have two reservoirs, A and B. Okay, so for example, isocratic, you maintain one ratio of A, one ratio of B. So means that 50% of A, 50% of B throughout the separation time. But for gradient illusion, you would set it is that for example, from 0 to 10 minutes, I want A to be 50% and B 50%. But from the 11th minute until the 15th minute, you want A to be 20% and B to be 80%. So when you have set this, so means that there are some gradient illusion will be created because you have changed the composition of the mobile phase throughout the run. Okay, you need to set this. So that is what meant by gradient illusion. So for example, what are the function of isocratic and gradient illusion? Isocratic mainly for you to be able to see the separation first. Okay, you have, for example, 10. 10 is quite a lot. But for example, you have three compounds, three analytes to be separated. So you do isocratic first. You set it, for example, 50-50, 50A and 50B. And then you do your separation and you will see that A and B is not well separated, but B and C is well separated. So you need to modify your mobile phase, which is what is gradient illusion is all about. So you modify your mobile phase to make sure that A and B is well separated while maintaining a good separation of B and C. All right. So that's how you manage on how to use isocratic and how to use gradient. When you have using isocratic and you see that everything is well separated, then you don't need you won't need to use gradient illusion. Okay. All right. So this is the figure of your isocratic. What is isocratic illusion and gradient illusion is all about. Okay. For example, in this figure, isocratic is shown as solvent reservoir. But for gradient illusion, you are using like two solvent reservoir. Okay, you want to show that there are some mixing here between A and B throughout the experiment. Okay. All right. So let's look at the situation here. Okay, you have a mixture of 6 components with different partition coefficient, hence very different elution times. Okay, so different partition coefficient means that different characteristic. So means that they will have a very different elution time. Okay, so when using isocratic elution, now we are using isocratic. Okay, isocratic means that is the same towards the towards the chromatographic run, alongside the chromatographic run. Okay, so using isocratic elution of mobile phase, now it shows that 90% of water plus 10% of methanol. So you would see that optimum for 1 and 2, which is good, the separation is quite good, but excessive time for 5 and 6. So means that even though 1, 2, 3, 4, 5, 6, all of the components are means more or less separated, but it is quite long. It is an optimum, means that it is too far away from each other. So there is some gap here, maybe 1 or 2 minutes gap between 2 and 3, and there are gaps also between 5 and 6. Between 4 and 5. All right. So then you would, for example, you do another isocratic where you decrease the water content, which is 85% of water plus 15% of methanol. Now you would increase the methanol punya concentration. All right. But when you do this, you will see that optimum for 5 and 6 only, but 1 and 2 and 3 and 4 is not resolved at all. Okay. But when you do 3 and 4, when you further decrease the water and increase the methanol, you will see that 1 and 2 is unresolved, 3 and 4 is good, 5 and 6 is improved in terms of time. Okay, so what do you need to do to enhance this? Means that you want everything uh, to be well separated and also to minimize the time so for it to become efficient. Okay, so that's how you do your gradient illusion. So based on this all three isochromatic, so you can think of using a gradient illusion. Okay, so you would have all of this composition and maybe decrease much more water and increase methanol, and you would have a better separation of 1 and 2. Okay. So this is an example of isocratic and gradient illusion. You will see that for isocratic, you would see that all of these components is not that good, not that have good separation, and 9 and 10 is quite far away. While for gradient illusion, you will see that most of it have much more better illusion, and the number 10 now is quite near to each other, which is good. All right. So these are the polarities versus illusion time for normal phase and reverse phase. All right, so you can have a read at this. This is very important. Okay, you need to be able to link between why normal phase is like this, low polarity, medium polarity is like this, why reverse phase high polarity is like this, and medium is like this. Okay, so you need to look at this and be able to correlate with whatever that we have learned before. Okay. All right. So example of HPLC separation in various compounds. So this is an example lah for separation for canola oil in terms of detecting aromatic hydrocarbons. You see that some of them are well separated. Some of them here is not well separated even in trace amount analysis. Okay. So this is the so basically this is the separation condition. Okay. So the mobile phase here, it's been using water and acetonitrile. So it's been using gradient illusion. Okay, so 40% of B for 5 minutes and then straight to 100% of B in 15 minutes. All right. So if it is a 40% of B, so the other 60% is A. Okay. It is being held for 5 minutes. But in the next 15 minutes, 100% of B. So A is 0. Okay. So this is how you write your gradient gradient illusion parameter. Okay. All right. So this is the separation of proteins. Okay. Also HPLC can separate proteins as well. Okay. All right. So this is the separation of drugs of abuse. You would see that but I believe that this is been using a very standard method. Okay. So you see that there is a lot. There is some good separation here between 1, 2, 3, 4. All right. All right. I think that's all for HPLC. All right. Thank you.